transforming sine and cosine. Okay, so last video, we graphed sine and cosine. This video, we're going to transform them. Let's just go right into the examples. Okay, here. This is like the one we did in class. There are a couple transformations that we're very familiar with. So we have an up 1, we have a left pi over 2, and we have this part of it would be a stretch by 2, and then this means there's also going to be a reflection. But remember, the way we graph that is just multiply all the y coordinates by -2. Now, I'm really hoping you know by now the normal sine pattern. If you were in class, we did the little table. If you watched the last video, we did the little table. I'm just pretty good at the sine function, and so I know if I make this pi over 2 and this pi and this 2 pi, so basically every 2 lines is another 2 pi, I know that sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and sine of 2 pi is back to 0, and then the pattern repeats. So if you can get used to that pattern, you will be in very good shape. I actually just graphed 2 periods here. Remember, period being the time it takes to repeat the pattern once. So here's a period. Period. Okay, so this is the parent function. Now I can start applying my shifts and such. So first of all, let me shift to blue. I like doing the stretches in blue. I don't know why. So all of the zeros are going to stay in the same place, right? Because I'm multiplying by 0. But when I go to multiply this point by -2, it becomes, well, 1 times -2 is -2. This point by -2, -1 times -2 is +2, and so forth. So this one is becoming -2, this one's becoming +2. So right now, as you can see, the graph is kind of stretched out, kind of interesting. Great. So let's now do the left pi over 2 and up pi pattern. Yeah, okay, so left pi over 2, remember each one of, I'm recording this at school, there's the bell. I hope the cleaning ladies don't come in. They may disturb me. Anyway, pi over 2, if you notice, is one grid line. Like every one of these grid lines represents an extra pi over 2. So moving left pi over 2 is really just moving left one grid line. So each of these points I'm going left 1 and then up 1. This guy left 1, up 1. This guy left 1, up 1. This guy left 1, up 1. And this guy left 1, up 1. Notice that my center line 2 is also now right at 1. In other words, my graph is kind of just repeatedly coming back to 1 all the time. So here's my first period, and then if I were to continue the pattern, it'd be like this. Here's my second pattern. So I know this is a little crowded on the screen, but the green guy is our final finished product. Pretty cool. So notice the center line is shifted up. Notice that the maximum value, let's just label these, max is now 5. The minimum is now -1. What's my amplitude? Well, that's 2. So the amplitude is 2. Notice that the amplitude matches the stretch. Since I stretched by 2, now my amplitude is 2. And remember, amplitude is the distance from the center line up to the top, or down to the bottom. Down to the bottom here, down to the minimum is also 2. Okay, great. Let's move on to the next one. Now, I need to introduce this new concept to you called a horizontal stretch. So this is a big new concept, a transformation that we've never done, because every time we've done stretches, they have been vertical stretches. Here, the multiplication is happening outside the sine, but here, notice that the multiplication is happening inside the cosine. Some textbooks do brackets like this to show you that actually this whole big expression is inside the cosine. But I do have multiplication happening inside the cosine, so weirdly, this is going to be a horizontal stretch, and I need to talk about what that is. This +1 is still going to be left 1. That doesn't change. All right, now, in order to deal with the horizontal stretch, things are going to get a little bit tricky. So let's actually make a table for our parent function just so that we can talk about some trends and patterns, because the horizontal stretch is going to mess with those. So here I'm just setting up a parent function table. This, like, if you just memorize it, you'll be in really good shape. Like, you can look at your unit circle to figure out these points, but I have it memorized. So here's my parent function. Now, what we need to keep in mind for the horizontal stretch is it's doing something like this. Here's the parent function. It looks something like this. The horizontal stretch is basically going to take this normal period of 2 pi and it's going to stretch it, right? So instead of it repeating every 2 pi, maybe it'll stretch and it'll get stretched out and maybe it'll repeat every 4 pi or 6 pi, something longer. This is what the horizontal stretch does. But exactly how much is it stretching? That's what I need to do. And I have this formula to tell me exactly how long it's stretching. We know that the normal period, I'll put normal period, the normal period is 2 pi, right? I repeat my pattern after 2 pi. That's something that we've talked about a lot. I need a formula to find my new period. And here is the formula. It's going to be 2 pi, which is the normal period, divided by this number. Let's call it b. I think that's what the textbook calls it. So they're calling the horizontal stretcher b. In order to figure out the new period, I need to go 2 pi divided by b. So let's do that in this case. Okay, so I have 2 pi. My b is pi over 2. I think it's easiest to think about this as multiplication by the reciprocal. So instead of dividing by pi over 2, multiply by 2 over pi. Here we see the pi's cancel, and I'm left with 4. So this is my new period. My new period is 4. So how does that help me? So let's look at our parent function. All of these y values, these are vertical values. They're not changing at all. What does need to change is the x values. Change the x values. They're going to be stretching so that the new period is 4. So here's the deal. I'm still going to start at 0. But now instead of taking 2 pi to finish a period, it's going to take 4 to finish a period. So this 2 pi needs to be 4. And of course, that's going to make all of these change as well. I need to figure out how do I get from 0 to 4 with nice even spacing. So here's the trick. If you divide whatever your period is by 4, that will give you the increment. In this case, it's 1. So if I go 0, 1, 2, 3, 4 for my x values, this follows a nice pattern. So I know this is a lot of information, but first step, find the new period. Second step, we know it's going to start at 0, and we know it's going to end at however long the period is in. To figure out the middle values, divide by 4, divide the period by 4, and it's going to be 1. Why do I divide by 4? Because there's 1, 2, 3, 4 intervals in between. So now I know the points to graph, and notice these are nice, easy points. Over 0, up 1, over 1, up 0, and so on. I don't need to rescale anything. Of course, I do need to take care of my left shift, so let's make that a different color real quick. Okay, so here's my new cosine, and you can continue the pattern a little bit if you want. It's going to be something like this. Okay, so this is my new cosine. There were a lot of steps in there. Of course, we'll talk about them more in class, but in general, to find the new period, go 2 pi divided by b. To find how much room needs to be in between points, divide that by 4. So, summary. Transformations are just like they always are, but we introduced a new transformation, the horizontal shift. In order to find the new period, use the formula 2 pi over b. That will tell you the new period. And then if we divide that by 4, that will give us our interval in the table. So actually on the summary, we have just a little bit of time. Let me just do one more example. This will take about, well, you can see how long until the end of the YouTube video. Let's say I have sine of 4. Sine of 4x. Okay, so this is a horizontal stretch. So I need to find the new period. New period. I'm going to do 2 pi over b, which is 2 pi over 4. And that reduces to pi over 2. So now I know in my xy table, instead of going 0, pi over 2, pi, 3 pi over 2, and 2 pi with the 0, 1, 0, negative 1, 0, I now need this period to finish at pi over 2. So this now becomes pi over 2, which means these points now no longer make sense. How do I find them? I need to divide pi over 2 by 4. So that would be pi over 2 times 1 over 4, so that's pi over 8. So take a look at what I'm going to do. From 0 to the next one, I need to add pi over 8. So this is easy. It's just pi over 8. Now I'm adding another pi over 8, which is 2 pi over 8. And we'll come back and reduce that later on. Then I need to add another pi over 8. It's 3 pi over 8. Now if I add another pi over 8, does it get me to pi over 2? And the answer is yes, it does, because it gets me to 4 pi over 8, which reduces to pi over 2. Now probably I should go back and reduce this 2 pi over 8 to pi over 4, and I'm good to go. Okay, hope that made it a little more clear for you. If not, well, we always review in class. So yeah, have fun with that. See ya.